Hello everyone. So I'll be talking about intuitive touchless interaction for medical volume visualization. I know title doesn't make sense, but hang on there. So what are we going to talk about? So this is how operating room looks like today. As you can see, a surgeon on the far side is performing an operation, and at the same time he's actually looking at the screen. And on that screen there is lots of information that is there to assist the surgeon during his operation. There is like medical visualization data and some other parameters, but as you can see on the other side of the outside of the operating room, behind the window, he has an operator, and that person sits there specifically to listen to the commands of a surgeon and to adjust the view of two-dimensional data or 2D scans, or basically any data upon request. And you can imagine this is not very efficient because first you need another person to sit there all the time, and second, the communication between people is not an easy task. So that's why we want our future operating rooms look like this. So we have a surgeon, he performs his operation, and at the same time he is able to control his software, like mostly visualization software, using his gestures. Why gestures? Why not mouse or keyboard? Because operating room has sterile conditions, so you are not able to touch things that you are not supposed to touch there. And that's why this is very important. Alright, so to build a system, what are the ingredients? What's the recipe? First, it's gestures. How to actually map these gestures, like how to create a vocabulary, how to create a language to be able to manipulate this complex software. Then, when you figure that out, you will need to find a smart way to actually visualize your data. Visualization is a huge task by its own, but combined with interaction techniques, you need some smart visualization techniques to make it all work. Then the last but not the least is actually interaction. So when you when you have your language, you zoomed in, let's say, into your heart, and you visualize it beautifully. Now, how do you actually pinpoint on that valve, that problematic valve that you want to inspect right now? How do you actually select it precisely in that crowded, dense data? So we're gonna start with gestures. What are technologies available? These are the technologies mostly used in interaction. Not going through all of them, but leap motion is great, high resolution, cheap, easy to use. So most of the research, state-of-the-art research, is focused on that technology. So let's go ahead and a little bit history, how it all started. Like, first people tried to map the gestures, like we had this mouse interfaces, like normal software. So people tried to basically map your gestures into conventional software. It would look like this, for example. One of the authors, he suggested to use open palm for panning, like to move your data around the screen. When you close your palm fist, it means that you're rotating the data. So again, in 2 dimensions, you can rotate the data. This will translate rotation. You can definitely see the problem there. You cannot rotate and translate at the same time. So it means to reach to some point, you need to perform 2 distinct operations. That's a problem. Some other authors propose to basically create a virtual touchscreen plane, and to interact with it with the conventional gestures that we all use, like pinch to zoom, panning, like tapping, just basically creating a touchpad in virtual space. However, the state-of-the-art says that this is all unintuitive. People are not used to this. You need to train, you need to get used to it. This is all not great. Therefore, authors suggest to use more intuitive gestures. Like, for example, if you want to interact with your virtual object, if you want to move it, then you have to, how would you do it in real life? You would grab into it, and then you would move it to the position that you want. Or you would grab into it, and you would rotate it. That's what Shen et al. Proposed, actually. Also, they proposed, for example, another metaphors, like for if you want to have a flashlight, if you want to point at something, then you just position your hand as a flashlight, and direction of it will determine the region of interest in a virtual world. Then you have a clipping plane. So clipping plane used a lot. It's one of the most used tools in visualization, and suggestion is genius. You just use your hand, and your hand directly maps into the plane. This is animation which does exactly what the paper describes, however it's different author. So what are the problems with it? Lots of work is going on there. Techniques are not adopted in medical environments yet. So because there is no gesture, like everyone proposes some interesting combination of gestures, but there is no complete solution that would allow to use all the functionality of the software together during the operation. So that's the big problem. Then, as I mentioned, most of the software is built to be used by mouse and keyboard, which is not great when you have gestures, because mapping from gestures in with 6 degrees of freedom to two-dimensional space just can't be intuitive. Also, all of the authors that I've seen, they perform user tests, not all of them, but most of them perform user tests. However, these user tests are all performed on their own test scenes with their own studies, and everyone claims that their work is better than the others. But how do you compare if everyone has their own tests? So it will be great to have standardized tests. Now let's quickly move on to visualization. Lots of things to tell about visualization. I'm just gonna, in this presentation, cover tip of an iceberg. So you remember I said like you can point onto data onto region that you want to see. This is exactly what this paper does. So what they're doing is like they created a visualization system which allows you, when you point at the object, it will create 2 different transfer functions. In the region of interest you will see let's say the focus data, like you will see it through the body, and the rest of it you will see the outer skin, to keep context. However, authors proposed to improve on that, and they said, alright, this is all great, but why we create just 2 distinct transfer functions? Let's create transfer function that depends on the distance from the object of interest. So for example, if you're trying to look at the kidneys, then as you can see, the objects that are closer to it, they're gonna be more in focus, they're gonna be more detailed, and the objects coming away from it, they will be, maybe I should do this, they will be more transparent, and they will sort of be out of focus. So the problem with visualization, like what should be done there, is a combination of all these techniques. Again, like lots of different papers doing lots of interesting things. However, nothing is combined and no unified solution to be actually used by surgeons. Also, this is all very computationally expensive, so hardware acceleration, people who love GPU, there is lots of work to be done there. Interaction, so when we started talking about actually touching the objects and pinpointing the things that you really need, that's super important. One of the also investigation is going on around camera control. So for example, how many of you have used some sort of how do you call it, inspection tool, like 3D? So you have an object and you want to inspect it. So what usually happens is that after several rotations, like you zoom out, you try to rotate, and then you don't see object anymore, because you accidentally moved away from it and you didn't expect, because it's not very intuitive, and your camera is looking there and your object is there. So this solution proposed to fix this. Instead of moving not randomly but freely around the scene, you will be your camera movement will depend on the scene itself. So you basically create shells around your scene. In this case it's face, it can be anything, it can be heart, it can be the studio, and then the camera will follow the shape of the object depending actually on the distance to it, which is a really great solution. However, yeah, let's keep it there. Then we have how to actually select objects. This is super interesting topic, because one of the things that radiologists do, they contour the problematic areas. How to do that in 3D space? That's complicated, because you have lots of data and everything is super crowded. There are lots of algorithms doing that. There's interesting research by Perizov. They suggest to use a guiding beams to assist basically selection process. Also really interesting paper, but don't have much time to talk about. So what are the problems here? The shell cam, that solution that works, it works really great, and people try to use it. However, it's not implemented for volume data because that solution is done for normal 3D renderings when you have surfaces, you have planes, but in visualization, everything is just data points. So you need to find a way to perform that in volume data. Then data reusability. What I mean by that, all these techniques again are super expensive, like to guide the beam to select objects, to control the camera, because you need to calculate surfaces. So there should be a smart way to be able to reuse data calculated in one technique to be used in the second one. Thanks for listening. I hope you have now idea what I was talking about. Any questions?